In this lecture, I'm going to talk about the PLC. So what is a PLC and how does it work in the circuit? So a programmable logic controller, or PLC, so that means that PLC stands for Programmable Logic Controller, is a ruggedized computer used for industrial automation. These controllers can automate a specific process, machine function, or even an entire production line. As you can see from this image that this is the PLC, it is a device. This is actually a computer. This computer is being programmed to do the circuit that before the PLC was wired together using a hardware devices. So as you can see that the old mechanical devices were wired together to form the circuit, but now using the PLC, the circuit is a software program that is uploaded to the PLC and then inserted in the circuit. So the PLC is a software circuit, okay, or a software or the circuit is a software program that is uploaded to the PLC, and the PLC is doing all of the operation. So that means that the PLC is used for industrial automation and machine function or the circuitry of an entire production line. So this what the PLC is. So what are the PLC benefits? A programmable logic controller is an industrial grade computer that is capable of being programmed to perform control functions, as we have explained. The programmable controller has eliminated much of the hard wiring associated with conventional relay control circuits. So that actually means that the PLC has eliminated much of the hard wiring associated with conventional relays, timers, and all of these mechanical devices that must be wired together to form the circuit. But now using the PLC has eliminated all of these hard process to be a software program. The circuit is now using the PLC. It is a software program that is uploaded to the PLC and then installed in the circuit. Other benefits include fast response, because now the circuit is a software program, so that means that the circuit has a fast response, because back at the times these circuits were mechanical devices that are connected together, so that means that there is a late response or a not very fast response, not like the software circuit. And also it is easy programming and installation, and has high control speed, network compatibility, troubleshooting and testing convenience, and high reliability. So that actually means that the PLC has high control speed, because this is a software program, okay, a computer, and the computer normally that has high speed in the response, okay, to the circuit or to the inputs and outputs. The network compatibility means that the PLC now is able to being connected to the network, to the internet, or to phones, or to any other software devices. So this is a benefit that the PLC has and the classic control wiring doesn't have. Troubleshooting also is very easy, because this is a software program, so we could access this program and troubleshoot the problem in the circuit, because the circuit is on a computer, so we could access the computer, or we could access this circuit very easily, not like the old circuitry, because the old circuitry was wires all over the area of the circuit. As you can see that back at the time that all of these were consuming a very large area, but the PLC has been doing it in a very small area. and also the testing convenience and has a very high reliability because all of these benefits. The characteristics of PLC control system. It has increased reliability, more flexibility, low cost, faster response time, communications capability, easier to troubleshoot, reduce 80% number of extension cord. As you can see that this is a very good solution for the large area that was consumed by the circuitry, the old circuitry. The PLC power consumption is very low and easy to learn programming languages because it is very easy to design a circuit and upload it to the PLC, because the programming languages of the PLC is very easy. Easy programming and changing programs. Okay, there is so many languages that you could use to program the PLC and upload your circuit. Adaptation in harsh environments, temperature, humidity, voltage functions, and all of that. Because in the old circuitries, it was a mechanical parts or mechanical devices. These mechanical devices were harmed by the temperature and the humidity, because these all are metals. So the metal is very it is not durable to the humidity and the temperature and all of that. But unlike the PLC, adaptation has a very good adaptation in harsh environments like the temperature, humidity, voltage fluctuations, and all of that. The structure of the PLC. The PLC has two main types of design. The first one is the fixed I/O. I/O means that this, as you can see, that I means inputs and O means outputs. So there is two types. The first type is fixed inputs outputs, and the other type is modular inputs outputs. As you can see that this is the fixed one and this is the modular one. I'm going to explain the difference between them in the next slides. The fixed, or we could call it also compact PLC, it is a typical of small PLCs that come in one package with no separate removable units. The processor and the input and outputs are packaged together, and the inputs output terminals will have a fixed number of connections built in for inputs and outputs. The main advantage of these type of packaging is lower cost. One advantage of fixed input-output is its lack of flexibility. You are limited in what you can get in the quantities and types of dedicated by the packaging. As you can see that the compact PLC or the fixed PLC has fixed inputs and outputs. There is specific or limited number of inputs and limited number of outputs. So I am limited at the quantities of the inputs and outputs that the compact PLC has. As you can see in this image, we have right here that in this section, this is the section of the input section, and right here is the PLC, the processor or the mind of the computer, and right here we have the output. So the output section. As you can see that at the input section we connect our inputs, for example push buttons, sensors, proximity sensors, read switches, all of the input devices. Okay, these input devices are the way that I need to send the signal to the circuit. In the PLC, the circuit or the processor, we upload our circuit. Okay, so the circuit, all of the circuit exists in the PLC. The output section is the section that we are connecting to it the output devices, like the contactors for connecting the motors and, for example, valves or pistons or of the output devices. As you can see that this is the image, or this is what a PLC, compact PLC looks like. The modular PLC, or the modular input-output type. It is divided by compartments into which separate modules can be plugged. These features greatly increases your options and the unit's flexibility. You can choose from the modules available from the manufacturer and mix them any way you desire. The basic modular controller consists of a rack, power supply, processor, module, CPU, input-output modules, and an operator interface for programming and monitoring. The modules plug into a rack. When a module is slid into the rack, it makes an electrical connection with a series of contacts called the back plane. Located at the rear of the rack, the PLC processor is also connected. As you can see from this image, that this is the modular PLC. We have the PLC, the flexibility of the PLC is that you can choose from modules available from the manufacturer and mix them any way you desire. The basic modular controller consists of a rack, okay, the main controller, okay, the PLC consists of rack and power supply and the processor and input and output modules, and also an operator interface for programming and monitoring. So as you can see in this type, we have at the main or the basic PLC, we have a power supply, okay, the processor exists inside, and there is some inputs and outputs section. There is input section and output section, and also there is an operator interface for programming. That means that sometimes consists of a display. This display, we use it to program on the PLC itself. Not we don't need to program the device using a computer. We could also program the device using this display that exists on the PLC itself. The best part in this type that we could add extensions to it, because this is a modular, so we could add modules to the rack of the PLC. As you can see from this image, we could put a module for accessing the internet, or a module for extending the number of the inputs and outputs, okay, all of that. So we could add any modules that we need. Module for adding external or adding numbers of inputs and outputs, adding network module, Wi-Fi module, or any other module that the manufacturer gives or allow us to put in its PLC. So the principles of the operation of the PLC. The signals from external devices like sensors, contacts, push buttons, all of that are first fed to the CPU via the input module. After receiving the input signal, the CPU will process and send the control signals through the output module to external controlled devices according to pre-programmed program. As you can see that this is the operation that the PLC is doing. As you can see, for example, that we have right here is the input section, and right here is the output section, and in the middle we have the processor or the PLC itself. We right here at the input section, we have number of inputs, okay. We connect to it the output of the input device. As you can see that this is, for example, this is a push button, okay. This is a normally closed push button. This normally closed push button allow the current to flow through it, so that means that this first input is 1. 1 means right here is that the value of the voltage is high, or the current is passing through this input. And as you can see, the second input device that we have right here is normally opened limit switch, and this is blocking the current from flowing. So that means that the value of the second input is 0. So that means that there is any current flowing through that input section or this input pin. So the PLC going to analyze this data and see what the circuit that has been uploaded is doing, and then output the result. As you can see that this is the circuit that we upload, but the symbols right here are different. So in the ladder logic language, I'm going to explain that later in the next lectures, that this is what an normally opened contact look like, and this is also what a normally opened contact looks like. And right here, this is what a contactor at the coil of the contactor looks like. So there is some differences in the in the symbols of the elements, or the symbols of the components at the ladder logic language that we are going to explain later. But as you can see that the processor takes the inputs, okay, the data of the inputs, and analyze it according to the circuit that has been uploaded to the processor, and then send the result of this circuit to the output section. So that means that the output right here is the result of the output here is 0. So that means that the pin of this output is 0. So the motor or the contactor is not going to be activated. So as you can see that this is all of the operation that the PLC is doing to the circuit. So we have learned that the PLC has two types: compact or fixed, and modular. And the job of the PLC is to eliminate all of the old circuitry, the mechanical devices that being wired together and consuming a lot of large areas, and there is some problems with that, like the late response, the problems that happens to the mechanical devices from the environment changes, like the humidity, the high temperature, or all of that, and the large area that these old circuitry was taking. The PLC has eliminated all of that, because the circuitry is a software program that is being uploaded to the PLC itself, and the PLC is taking the signal or the input data from the input devices and then analyze it according to the circuit uploaded to the PLC, and then send the result to the output section, so the motor will be activated or not according to the circuit. So as you can see, that's it in this lecture. Thanks for watching, and I hope to see you in the next one.